In a modern energy facility, scale is absolute. Every turbine, compressor, and pipeline operates under immense pressure, leaving zero margin for error. A microscopic hairline crack or an inaudible vibration in a single pump can cascade through the system in minutes, bringing production to a halt and triggering millions of dollars in losses. For decades, industrial maintenance relied on fixed calendars. Technicians ran routine checks based on standardized schedules, regardless of how the machinery was actually performing. This rigid approach meant facilities often operated in the dark. They had to wait for a part to visibly fracture or fail before initiating repairs. To secure continuous production, the industry required a method to see those fractures forming in real time. This logic drives the move toward predictive maintenance. OmniPetro functions as the intelligence network for these facilities. It continuously monitors live operational data to intercept mechanical stress before it manifests into physical damage. Because in the energy sector, reacting to an accident guarantees a loss. True operational safety requires anticipating the breakdown long before the alarm sounds. To achieve that anticipation, OmniPetro deploys a dense physical layer of sensors. These units constantly measure the vital signs of massive assets, tracking temperature, pressure, and operational load. This data feeds into a system evaluating asset integrity, measuring not just whether a machine is turning, but its long-term structural resilience against compounding stress. This diagram visualizes the earliest warning sign of that stress: vibration. Through precise vibration analysis, the platform captures the exact rhythmic baseline of a machine and scans for the slightest irregularity. A microscopic shift in frequency, entirely undetectable by human hearing, is immediately isolated. The system interprets this tiny acoustic change as the physical precursor to a damaged bearing or imminent mechanical collapse. Industrial hardware broadcasts its eventual failure in these quiet, high-frequency signals. OmniPetro provides the exact analytical sensitivity needed to listen. Once that anomaly is flagged, the artificial intelligence takes over. It contextualizes the live reading by comparing it against decades of historical records and operational models. The algorithm calculates a highly specific failure prediction, mapping out the exact operational hour the machine will seize and the physical extent of the resulting damage. This split-screen schematic demonstrates how OmniPetro verifies this safely by constructing a digital twin. This virtual replica mirrors the real-world equipment flawlessly, reflecting its live data stream and current load. Pushing this model forward in time artificially accelerates wear, simulating structural collapse. The facility can effectively experience the entire trajectory of a disaster and map out its consequences entirely within a safe virtual environment. Knowing when a machine breaks is just the first step. The system must locate exactly why the stress began. OmniPetro reverses the timeline, tracing the sequence backward to the initial microscopic origin. This diagnostic work addresses the underlying mechanical disease, not just the symptoms. By isolating and neutralizing the exact origin point, the threat is permanently removed, securing the long-term viability of the equipment. This foresight changes the atmosphere on the facility floor. The panicked sirens and emergency shutdowns of a sudden breakdown are replaced by quiet, deliberate action. Long before the predicted failure date, the system automatically calculates the required logistics, ordering the exact replacement parts and scheduling the necessary downtime. The platform does not remove human expertise from the equation. Instead, it provides technicians with total operational foresight, giving them the exact data they need. An engineer reviews the system's analytical roadmap, evaluates the physical state of the machine, and executes a planned surgical repair under completely safe conditions. The true efficiency of OmniPetro is found here, seamlessly pairing predictive machine intelligence with the decisive physical execution of skilled engineers. When scaled across an entire facility, this model improves personnel safety, extends the operating life of equipment, and reduces environmental emissions. Industrial maintenance transitions from a reactive gamble into a controlled, highly predictable science. But this physical stability is only part of the equation. We must consider how the health of a single valve scales up to impact corporate profitability and ultimately global energy markets. In our next episode, we will follow that data upward to explore energy management, profitability, and how local operations link directly to the global economy.